Okay, so today we are going to start the numerical problems of chapter 2 physics. And before I started, I have a suggestion for you that you go through the earlier two videos in order to understand the numerical problems properly. Okay, let's start with our first problem. Okay, so here is our first question. A piece of solid has a mass of 10 gram. When it is completely immersed in water, the water level rises by 5 milliliter. Determine the density of the solid. So we have an object, or we have a solid piece of solid which has a mass of 10 gram. Okay, now suppose there's a can and the water level is at V1, and when this mass is lowered into the can, measuring can, the water level rises and reaches up to V2. Now this region is 5 milliliter. Okay, this region is 5 milliliter, or we can say 5 milliliter is V2 minus V1. V2 minus V1 is 5 milliliter. Now in order to find the density, what do we need to do? We have m by V2 minus V1. This is how you find density, right? Now what is the value of m? The value of m is 10 gram. And what is the volume which has been increased, which is 5? So how much do we get? 10 by 5, 2 gram per milliliter. Now this is going to be the density of the solid. Okay, so this is our second question. A rectangular piece of wood measures 4 centimeter, 6 centimeter by 8 centimeter and has a mass of 20 gram. What is the density of the piece of wood? Will this piece of wood float in water or not? Okay, so this is going to be interesting. So we have a rectangular piece of wood and it looks like this. Okay, so this is the rectangular piece of wood which measures 4 centimeter by 6 centimeter by 8 centimeter. These are the dimensions of this piece of wood, and it has a mass of 20 gram. Okay, so what is the density of the piece of wood? What is the formula of density? Density equals to mass per unit volume. Okay, so this rectangular piece of wood looks like a cuboid, right? So what is the formula of cuboid? When you are trying to find the volume equals to L into B into H. That means 4 into 6 into 8. That means 24 into 8, which is 192 centimeter cube, right? Now it's easy to find out the density. Mass is how much? 20 gram, or you should not write gram over here. 20. What is the volume? What is the value of volume? 192. Now put 192. 192. Now when you calculate this, you get 0.10 gram per centimeter cube. Now this is the density of the rectangular piece of wood. Now the second question says, the second part of the question says, will this piece of wood float in water or not? Now how would you determine will it float in water or not? Water. As we know, the density of water, let's write, what is the density of water? in CGS. Density of water in CGS, which is 1 gram per centimeter cube, right? Now this piece of wood has a density of 0.10 gram per centimeter cube, right? So as we can see that 0.10 is less than 1, means the density of the rectangular piece of wood is less than the density of water, and when the density of the substance is lower than the density of water, it floats, right? So from here we can say the piece of wood will float as it has the lower density when it is compared to the density of water. So that's the complete question. I hope you have understood. Let's do the third question. Okay, so here we have our third question, and the question says the relative density of oak wood is 0.64. What is its density in the SI system as well as in the CGN system? Ho 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 ho. Now this is going to be interesting as we have the SI system and the CGN system both in the same numerical problem. This is going to be interesting and this is going to be easy as well. So don't worry. So let's talk about the first part of the question, which is about the SI system. Now let's write relative density as RD. So relative density, what do you mean by relative density, or what is the mathematical expression? We can write relative density equals to density of oak wood, okay, density of oak wood and density of water at 4 degrees centigrade. Okay, so this is our mathematical expression of relative density. That means density of oak wood to density of water at 4 degrees centigrade. So we need to find out the density of oak wood. So let's do this. Let's write density of oak wood is equals to relative density into multiply density of water at 4 degrees centigrade. Okay, now what is the relative density? Relative density is given, which is 0.64. And what would be the density of water at 4 degrees centigrade in SI? Do you remember this? Yeah, it is 1000 kg per meter cube, right? Yeah, 1000 kg per meter cube. We have taken 1000 kg per meter cube because as the first question says, we have to find the density of that oak wood in SI system. So in SI system, the density of water at 4 degrees centigrade is 1000 kg per meter cube. Now it's a simple multiplication. We get 640 kg per meter cube. This is the density of oak wood in SI system. Okay. Now the second part of the question says we have to find the same thing, I mean the same density of oak wood in CGS system. So we need to change certain things. What is that? Up to this all remains same. This 1000 kg per meter cube in SI, what would be the value of density of water at 4 degrees centigrade in CGS? it's 1 gram per centimeter cube. So let's write, this is the second part of the question I'm doing. Everything remains same without this. 1 gram per centimeter cube, right? And after doing the multiplication, we get 0.64 gram per centimeter cube. So this is your second part of the question. This is the answer of the second part of the question, which is 0.64 gram per centimeter cube. Very easy guys, very easy. Let's do the fourth question. So yes, we got our fourth question. The capacity of an RD bottle is 100 cc. Okay, 100 cc is 100 centimeter cube and its mass is 45 gram. That means we have an RD bottle. Okay, the mass of the RD bottle is 45 gram and it has a volume of 100 centimeter cube. Okay, find the mass of the bottle when it is filled with a liquid of density 600 kg per meter cube. That means we have a liquid which has a density of 600 kg per meter cube. Okay guys, so do you observe one thing, that 600 kg per meter cube, we have 45 gram 100 cc over here. That means we have a combination of CGS and SI units. So when we have this kind of combination, the SI unit must be converted into CGS unit. So meter cube must be converted into centimeter cube and 600 kg must be converted into gram. Okay, let's see how we are going to convert meter cube into centimeter cube. As we know, 1 meter equals to 100 centimeter. Now if I write 1 meter whole cube, the same thing we need to do on our right hand side, 100 centimeter whole cube. It becomes 1 meter cube equals to 1,000,000 centimeter cube. So from here we have understood that 1 meter cube is equals to 10 lakh centimeter cube. Now we have to convert 600 kg into gram, which is very easy. 600 into 1000 gram and it becomes 600,000 gram. Okay, the process of conversion is complete and now we have to do the sum. How to do this? What is to be found out? We have an empty RD bottle which has a mass of 45 gram and it has a volume of 100 centimeter cube. Now this liquid, when this liquid is poured into the RD bottle, obviously the mass is going to be increased, right? So we have to find out the final mass, means the mass of the empty bottle plus the mass of the liquid. This thing we need to find out. In order to do that, we have to find in 100 centimeter cube mass, in 100 centimeter cube of volume, what is the amount of mass the relative density bottle is going to contain. Let's find out. So in 1,000,000 centimeter cube, the amount of mass we have 6,000,000 gram. So in 1 centimeter cube, the amount of mass we have is 6,000,000 by 1 gram. Okay, now we need to find out in 100 centimeter cube what is the amount of mass we have. So in 100 centimeter cube we have the amount of mass we have 6. Okay, let's cancel this. 1 2 3 4 5, 1 2 3 4 5. That means we have 6 by 10 into 100 gram. 0 0 cancelled. We have 60 gram. That means the relative density bottle can contain 60 gram of mass of that unknown liquid in that relative density bottle. Now the mass of the relative density bottle is 45 gram, and the mass it can contain is 60 gram. So plus 60, right? So what will be the total mass when this liquid is poured into the relative density bottle? We have 60 plus 45, that means 105 gram. Now this is your final answer. I hope you have understood. If there is any problem regarding any part of this question, please comment below so that I can reply, okay, and make you understand completely. Okay, so this is the complete scenario, and we have to do our last sum, question number 5. Okay, let's proceed to question number 5. Okay, so we got our question number 5, which says an empty RD bottle weighs 60 gram but weighs 120 gram when completely filled with water. When the bottle is completely filled with an unknown liquid, it weighs 90 gram. Calculate the volume of the RD bottle and the density of the unknown liquid. So let's start. We have an empty RD bottle. Let's say this is an empty RD bottle. Okay. And when the RD bottle is empty, the mass is 60 gram. And when water is poured into it, obviously the mass is going to be increased, and the total mass becomes 120 gram. So from here, and the total mass becomes 120 gram, and from here we can easily write that the mass of water becomes 120 minus 60 gram. That means 60 gram. So 60 gram is our mass of water. And the same thing happens with the unknown liquid. We have the empty RD bottle which weighs 60 gram, and when the unknown liquid is poured into it, the weight increased and it becomes 90 gram. So the mass of the unknown liquid becomes 90 minus 60 gram, and it becomes 30 gram. So the mass of the unknown liquid becomes 30 gram. Now let's talk about the first part of the question, which says you need to find the volume of the RD bottle. Now in order to find the volume of the RD bottle, we need to use the formula of density, and it says let's do part A. So we can write density of water at 4 degrees centigrade equals to mass of water by volume. Now this volume is the volume of that RD bottle. So density of water at 4 degrees centigrade is 1 gram per centimeter cube. We should write 1 because see, we have gram over here. That means the unit is in CGS system. So 1, and mass of water becomes we have the mass of water 60 gram, right? So let's write 60, and V we need to find out. So therefore volume of that RD bottle becomes 60 centimeter cube, or you can say 60 cc. Clear? Now let's talk about the second part of the system, which says you need to find out the density of that unknown liquid. Okay, part B, density of unknown liquid equals to mass of unknown liquid by volume. Now this volume is same with this volume, because when water is poured into the RD bottle, the unknown liquid also poured into the same RD bottle, so that's why volume remains same. So density of unknown liquid you need to find out. So mass of unknown liquid is how much? 30 gram. So let's write 30, and volume, which is 60 centimeter cube, 60. So when you calculate, you get 0.5 gram per centimeter cube. Now this is the answer of your part B, and the density of the unknown liquid becomes 0.5 gram per centimeter cube. So this is our complete sum. This is the end of this numerical problem. I hope you have understood. Okay, so we have come to the end of this video, and I'm going to finish this video by saying that if you do not understand any part of it, please comment below so that I can clear your doubts, and I can assure you I will definitely reply. And if you like the video, I mean, if you understand each and every part of that video, so please like. And if you think that it would be helpful for you in future, please subscribe. And I'm sure you will be benefited. Thank you very much. This is Pritam Shah signing off.